this particular topic is about introduction to SAP ISU. The first slide gave the definition of utilities. So what utility actually means? Utility means the services like transportation, telephone, telegraph, electricity, natural gas, water and wastewater. But for all practical purposes, when we say SAP ISU, we actually mean electricity, natural gas and water and wastewater services. This is like the bird eye view of what the electric industry comprises of. This is like the bird eye view of what the electric industry comprises of. So basically, electric industry comprises of three core subsectors. The first one is generation and trading, second one is transmission and distribution, and third one is retail and supply. At the bottom of this slide, you can see the pictorial view of how the electricity is being generated and then is supplied to the house. So the first one is the electricity generation center, which generates the electricity through multiple ways like thermal generation, hydro, nuclear, renewable, non-renewable, and so and so. So once the electricity is generated, it goes through point number 2, which is basically a step-up substation. Here the voltage level of that electricity is being increased, and then it's transmitted through number 3. Number 4 is a step down substation, where the high voltage is put down to low voltage, and then number 5 is the transmission line, and then 6 is the household where electricity is supplied. This is building block of power system. So I would request you to carefully look at this particular slide and try to understand each and every aspect of it. So there is a generation station which is generating 13.8 kilovolt of electricity, and then there is a step-up transformer which increases the voltage of electricity generated to 69 kilovolt, and then this is transmitted through 220 kilovolt line, 750 and 69 kilovolt lines, till it goes to a switching station, which is transmission substation. And then this switching station basically is switching it between two downstream substation. So as you go down, you can see there is a distribution substation which is reducing the 35 kilovolt to 12.47 kilovolt. So this is called the step down substation. And actually, so basically the concept is transmission is carries over high voltage level, and then distribution is basically at the lower voltage level. Then from this distribution substation, you can see there is a feeder line coming out. So in the middle, you can see from the yellow one, there is a 3-phase feeder, and then from this feeder there is a single phase line, and then there is a service transformer which reduces further the voltage to 220 or 240 voltage level. Okay, this is very interesting slide actually. This is something you may have heard many a times, which is called a smart grid. So this particular slide is basically having traditional generation, transmission, distribution line, and then how the smart appliances are being incorporated into this traditional line, and then what are the futuristic services that is coming out of it. So basically, as you have seen in the previous slides, there is a generation, transmission, distribution, and then the consumer. That is all right, but all has these embedded processes into it, which is giving it sense of smartness. So basically, as you can see, in the transmission line, there is a load planning coming into picture. Then the GIS, which is Geographical Information System, is being incorporated from generation till the consumer. Energy management is there, SCADA is there, and then one very important aspect, which is outage management. So I just wanted to give you a feel of what all is there into device management. So this is the sort of things that is covered into device management. So device management, as many of you may have heard, is not just the inputting the giving the reading into the system and then validating it and giving it to billing guys to generate the bill. It's much more than that. It's basically as you can see from here. So advanced metering infrastructure, AMI, is something which is futuristic things and which is coming very fast. So consumer is basically, then CRM system is there, CIC is there, demand response system. Demand response system is something which is giving control to the consumer. So basically consumer will demand like what is the current consumption till current consumption for this particular month, and then the system will be able to give that. Then there is a plug-in hybrid electric vehicle with a car, which can be charged from this particular network. And then there is two-way flow of information through home area network. So home area network is basically where your smart devices will talk to the utility. Okay, this is the extension of previous slide. So it's giving the main attributes of a smart grid. So what are the new embedded processes, and what are the new concept that comes in the smart grid. So as you can see here in the smart grid, you can have distributed generation. So in classical electric network things, there were linear generation, transmission, and distribution. But here in a smart grid, you can see there are distributed generation. So there you can see there are wind farm coming in the block of distribution. And then there is two-way flow of information. So earlier it was just the electricity coming from substation to the customer, but now there is a two-way flow. Customer have a say. A customer have a command of the information that is generated in substation. It can actually trigger something and get the information from there. Then there is a plug-in hybrid electric car concept which is coming into picture, and it's basically you can charge it from anywhere, and then that charge should be levied to your bill irrespective of where you are located. So this will actually is basically complex scenario comprising of GIS, geographical information system, your network hierarchy, plant maintenance aspect comes into picture, and then all lot of new concept comes in. So there is embedded processes into smart appliances that is implanted into generation substation, is implanted into transmission line, distribution line, and so on. This is natural gas value chain, which is similar to electricity that we have seen earlier, but there is a difference here. Actually, supply and transmission segment are covered into oil and gas segment, but here in SAP ISU we have distribution segment only. So you can say there is exploration, production, then storage and pipeline, and then there is a distribution. So you can see the customer can be commercial and residential. They can use this for industrial and power generation. This is the value chain of water and wastewater. So as you can see up left corner, this is the value chain of water. So water intake and distribution infrastructure are depicted here, and then the water is treated and purified and supplied to the household. In the down picture, you can see the wastewater processing and reuse. Let us understand what is a regulated and deregulated market. Regulated market is where basically production, distribution, transmission, and supply, the whole value chain of utility is being handled by single entity. Most of the time is the government, which is basically the producer, which is also a distributor, which is also a supplier. But in deregulated market, there is a competition involved. The basically unbundling of generation, transmission, distribution takes place. As you can see in deregulated market also, basically transmission line for its basic nature is remain monopolistic. This only because there is no benefit of having multiple transmission line, because that cost a lot. So what actually competition brings in is basically for production and for the supplier. So you can have multiple production company involved, and there is a competition, and there is a private player coming to production unit, and then in the supply unit there the competition involved. As you can see here, the competition has brought in two new players into picture, which is traders and retailer basically. As you can see, the deep blue line, which is the physical flow remain unchanged. So from producer to transportation and distribution to client, that particular blue line remain the same. But the information flow and financial flow, you see a web of it generated into deregulated market. So there are traders which comes into picture, which buy the electricity generated from producer, and then it sell it to the transmitter, and then transmitter, the retailers come into picture. It takes from transmission line, and then it sell to the client. Here you can see in deregulated market there are 5 entity: transmission company, distribution company, supplier, exchange and bilateral contracts, and business partner. So let me explain you what is exchange and bilateral contracts. So when there is multiple buyers and multiple sellers, so just to deal the price based on the demand and supply, there is the energy exchange created whenever there is a deregulated market. Even in the regulated market, when there is the open access, like one entity can buy electricity not only from its traditional one, but also from outside, then there is an energy exchange created for that. So there is an energy exchange when there is multiple buyer and supplier, and then there can be the bilateral contract when there is one supplier and one transmission company. So basically through multiple contracts and through exchanges, the supplier buy electricity from distribution company, which basically then deal with the transmission company. So basically here in whole deregulated setup, the beneficiary is the business partner, with the consumer. So consumer gets the best price best priced electricity from the supplier. Okay, so once you have a fair idea of what the utility is, now the question is why SAP came up with industry specific solution. Now the answer lies with is basic philosophy of the business itself. Every type of business has its uniqueness. So basically what we actually mean by that is the business processes involved in one industry may not be completely applicable to other industry. So for example, the automotive industry and manufacturing, steel manufacturing industry, the business process in both the industries are entirely different. So automotive industry is basically based on the concept of discrete manufacturing, whereas the integrated steel plant is basically continuous manufacturing unit. So basically just to deal with each uniqueness of each industry, and then to give the ready-made solution to it, SAP came up with industry specific solution. By coming up with this solution, actually SAP answered the challenges that came up. One of the few challenges that came up and which answered by coming up with industry specific solution is like emerging market. And then the emerging market is basically from emerging market, the revenue started coming up, and then public utilities company in this emerging market started going for the ERP solution. Then there's competition involved. Then there is increasing demand, labor issues, and workforce shortage. So all these combined together gave a thought to SAP team, and then they came up with industry specific ready-made solution. This is the functional scope of SAP ISU system. SAP ISU system has concentrated on customer services and billing. So it's starting from meter reading and device management, is a consumption entry, consumption billing, invoicing, and contract account receivable and payable are the modules that is being covered into SAP ISU system. So this particular picture is giving the linking of the SAP ISU system with the standard SAP R3 modules. This is integrated and open system landscape. So there is SAP CRM system, which basically stores the business object such as business partner, agreement, contract, product, sales and distribution project. Then there is SAP BW, and then SAP ISU is talking to both these systems. So SAP ISU talks to SAP CRM through middleware, and then data flows from SAP ISU to CRM both ways, and then from SAP ISU to BW both ways. So this is the how integrated and open system landscape looks like. SAP ISU is the master for device management, billing, invoicing, contract account receivable and payable, intercompany data exchange, energy data management. These are the modules that is there in SAP ISU system. Data entity that get exchanged between SAP CRM, BW and ISU are basically business partner, contract account, contract, transaction object and point of delivery. This is the system infrastructure how the data get exchanges between utilities, business warehouse and CRM. So please go through this. This seems very self-explanatory. How data are being exchanged between all these three systems. This is the interlinking of ISU modules with SAP ISU core applications. So you can see there is industry solution, there is core application, and all these core applications are one or other way linked with these SAP ISU modules. So once you go deep into these modules, actually you will see how R3 and ISU the modules are basically interlinked. This is integrated component of SAP Enterprise Information System. So how SAP ISU is basically linked to the R3 modules, and which components are basically covered into which core modules. So this gives a bird eye view of interlinking of utilities with core R3 modules. This gives how the ISU modules are being integrated with the core modules, and what are the data that get transferred from one module to another module. So basically material master record of are managed in MM, but device category in ISU actually is the material that is created into material management module. Similarly, there is a network hierarchy created into plant maintenance, but that get linked to the connection object. Then there is sub-ledger, which is contract account receivable and payable, which actually basically deals with the large volume of customers that get linked with the core application component. So this is how the data get exchanged between the core modules and SAP ISU. So you will get each one of these data flow and its details once you go through each one of these modules. So basically you will get to know what are the network hierarchy and what is the function location and how it's linked with the ISU once you will go to the connection object. So this way you will get to know what are the exchanges happening between these modules. these are the central data objects and its linking and its integration with the logistics module basically. So on the top of it is the business partner. The business partner has a contract account. Contract account and installation are linked to the contract. Installation has premise linked to connection object. Installation has device and installation are linked through premise and device location. Then device has registers, which is basically used for meter reading services. Registers are clubbed together into register group. Device category has one register group. And then device location is linked to the connection object. Connection object has regional structure. So don't worry about it. As and when you proceed into respective modules, you will come to know the details of each one of these entities. This is meter to cash process that is being covered into SAP ISU. Let's start with the field and meter services. So there are meter servicing, service order management, service order execution, new customer installation, meter inventory. Then there is a meter reading management. So meter reading, automatic meter reading, retrieve and process interval data, demand management, route management, equipment management. Then there are billing services, which is bill calculation, bill generation, bill printing, exception and adjustment management. Then there are revenue management, rates and account services, customer accounting, credit and collection, payment processing. Then there is a customer contact center is there, correspondence, e-services and self-services, local offices, customer relations. So in SAP ISU, basically all these are covered in respective modules. This is the small depiction of how the bill is getting generated. So there are master data set up first, then the meter reading is entered into system, the bill is generated. After bill, invoicing happens, and then the invoice is printed and sent to the customer, and then the contract account is being reflected with that. This is the very high view of how the bill is generated basically. So it's a start with the order creation, and then the meter reading is being uploaded into system either manually or automatically. Then the bill is generated, invoice is generated, and a printout is being sent. This is the detailed entity relationship diagram of SAP ISU and the R3 modules. So please keep this as a reference and keep on referring it. This is the entity relationship diagram of SAP ISU. So basically top three: customer, business partner, account, and contract. This is something called the business master data, and down below installation, premise, connection object, and device location are called a technical master data. These BMD and TMD are linked through the process called move bin. Billing portion and a meter reading unit is something that fall into scheduling. So basically scheduling gives you an idea when installation has to be read and when a bill has to be generated. Regional structure gives the address hierarchy. So basically it links the city to the street and street to a street section. This is the typical ERD process, which is depicting the cardinality as well. So connection object and premise are linked through one-to-many cardinality. So one connection object can have multiple premise. So similarly, one premise can have multiple device location, and one device location can have multiple installation. Installation to contract is one-to-one, and multiple contract can be clubbed into one contract account. Contract account, there can be one contract account to one business partner, and then the business partner contract account is moved in process through premise. This is one of the business scenario that it doesn't mean that your case should be exactly in the same way. Like in your business process also, it should be one connection object should have multiple premise. This is the one of the business scenario, and that depends on the business that you are going to implement the SAP. This keeps the connection between SAP ISU and plant maintenance. So basically, connection object in SAP IS-U is a function location in plant maintenance. Connection object in SAP IS-U is the ISU house, and which has basically attributes like a street, house number, postal code, city, district, and county, which is the function location in plant maintenance. Device location is also a function location in plant maintenance, but the structure indicator there is different for the connection object and device location. So device location, as you may be knowing or you will come to know, is basically the location where device is installed into SAP host. This is how SAP ISU is linked to material management. So basically, device category into SAP ISU is the material in material management. Device category has few attributes like basic device category, division, description, function location, regional register group, and in the material in material management has few attributes like material number, description, division, and basic units of measurement. Okay, this is giving the linking between utilities, material management, and plant maintenance. So basically, device category in ISU is same as material in material management, and which has got basically equipment in plant maintenance. This is giving the interlinking of utilities with plant maintenance and material management. So basically, connection object and device location in SAP ISU is the function location in plant maintenance. Device in SAP ISU is equipment in plant maintenance. Device category in SAP ISU is material in material management. By this we came to the end of utilities description and giving a brief idea of what SAP ISU is and what utility is. So I would request you to please go through it again, and each and every aspect that is being covered here, it will be the detail of that will be covered into each and every module. Thank you.